There we go. Let me see.
All right, looks like we got folks trickling in here. Welcome, everybody. Welcome. We're excited, glad to have everybody here with us this afternoon. We have a great session. We got some great guests, some great folks that are going to be speaking. After we have our company spotlight and then we have our guest speakers present, we're focusing on education. We will, as always, the last Friday of every month, be opening up our conversation open forum here. We'll be having Miriam McNabb with Drone Life kind of presenting some topics. We're just kicked off not too long ago. So again, we're given a minute here to kind of let folks continue to move in before getting started. Welcome everyone. I hope everyone's having a great morning, evening, afternoon, depending on where you are located around the world. I'm Paul Rossi. I am the Community Outreach Coordinator with the AUVSI North Carolina chapter. Joining me today as our additional moderators, we have Kiana Wells. How you doing, Kiana?
Doing well.
Awesome. Excited. Thank you. You know, we've put in a little time. We've reached out, gotten our guests, and we're excited to kind of present. And then also helping us with some questions, and then carrying on our conversation, we have Miriam McNabb, as always, with Drone Life. Excited, glad to have you here, Miriam.
Always happy to be here.
Awesome. And then for the folks, before we get started here, one thing we wanted to mention is coming up in August, we have AUVSI Exponential. AUVSI Exponential will be taking place. There is an in-person in Atlanta, Georgia. Very exciting. Any folks in the Southeastern area or any folks in North Carolina that have kind of found value from what our chapter is putting out in regards to content. If you have the ability to get out to an event like this, it's going to be amazing for building your network, and the information you can learn there, it's stuff you're going to be able to take back and apply to what you're doing in education, business, and research. All right, well, I think at this time, what we can kind of do is get rolling into things. We, again, AUVSI North Carolina chapter, our event today, this is Let's Talk Drones, the last Friday of every month. We are getting together. We're highlighting and spotlighting a company in North Carolina. So if you know, if you are a North Carolina company, if you're aware of a company in North Carolina that might have information or is providing services, support in this unmanned industry. It doesn't have to be air, it can be ground as well. Please, bring that to the attention of us, any of the members, make suggestions. And we're always looking to recognize and highlight and spotlight those companies here doing great things in the unmanned industry. And Drone Life, big shout out to Drone Life again as a supporter. And if you have any questions about AUVSI, if this is your first meeting, please, you can shoot a message to myself, Kiana, to the AUVSI North Carolina chapter. We got Nicole Ramsey, who is, the person behind all this, helping us make this happen. So if you have, hey, Nicole, she's right there, shoot a message to the AUVSI North Carolina name in there and ask any questions, or you can learn about memberships. So today we're talking about education. We've got some great professors and doctors here with these different education institutions. They're going to have an opportunity to present what it is that they're doing. But before we do that, we're going to jump into our company spotlight. And this month we have Stemrold City, based in Fayetteville, North Carolina. And we have with us Jeff Epps, the CEO of Stemerald City and a huge STEM education activist, has spent a lot of time in education with an IT background and has really observed what has gone on in education for the last many, many years. And now he is working with organizations, schools all across our great state and outside the state, helping them do some pretty awesome things. And I have had the pleasure of connecting with Jeff through Fayetteville State University and 910 Drones. And I'm really excited and to have the honor to now introduce you, Jeff, in Stemerald City. The stage is yours.
Thank you so much, Paul. You know what? You're getting so much better at this. This dude has come so far. When I first met Paul, we were just two young entrepreneurs trying to take on the world and be titans of industry. And, Paul just sort of latched onto me and became my mentee. And wow, dude, I just want to tell you how proud I am of you. You've grown so much. So in such a short time. So, the great thing is he kind of already told you about my company, which is great. And that's what I love about Paul, because he's able to tell my story now. So I can really jump into, what Stemerald City is passionate about and how do we take drones and drones in education and create that pathway that we so much desire. Because as I talk with educators all the time and we start talking about drones and UAVs, I constantly hear pathway. Well, how do we create that pathway to the high school? Well, logically, we start at the middle school, but we also have to consider elementary as well, grades 3 through 5. And to begin, for example, we want to look at how do we cast a bigger net to really increase that pipeline going to the high school, because right now that net's pretty small. And when you hear about drones in K-12 education, you usually hear about it at the high school level, and it's usually a career and technical education class. And that's not a ding on anyone. It's a perfect fit, right? It's careers, it's pathways, and it could lead to jobs. However, if we focus solely on career and technical education, that's a small net. We're only going to reach a small population within our school districts, okay? I mean, you take a middle school with 1,600 or 1,300 kids, if you only run these sessions through career and technical education, you're only reaching a small group of kids. So now, how do we cast that bigger net, right? Well, we can start by integrating drones not only into CTE, but into the English classroom, into the math classroom, into the science classroom, to the social studies classroom. We could even integrate it into the physical education classroom as well as the CTE classroom. That creates a bigger net because now we're reaching a broader range of students, no matter where they are in the school building. Now, some people might be saying, that's easier said than done. I agree with you, but Paul and I know that it can be done because we've done it, okay? It's happening right now here in North Carolina. So I'm going to use as an example the Northeast Academy for Aerospace and Advanced Technologies in Elizabeth City, North Carolina, right there with Elizabeth City State. And I've been contracted to work with their teachers for the last 2 years. And yes, last 2 years during COVID. Okay, so I want to make sure that's emphasized. I was contracted to work with them during COVID to integrate drones into the high school and middle school levels. And I work with Paul on some of these projects where we use the telos to advance coding skills, math skills at the high school level. We then integrated a drone build session into their high school during the summer. But then the following year, we started working with their middle school teachers. And so now we're 2 years into it, and we have a a charter school that's very fluent in not only integrating drones into the math, science, social studies, English classrooms, but they're also fluent. These kids are fluent in coding as well as higher order and higher level thinking skills. So we've now cast a broader net with the NEAT Academy. We're reaching more students, and that's the key to driving this particular pathway. Now, so what does something like that look like? Well, at the NEAT Academy, we primarily work with the teachers on PBLs, right? Project-based learning activities. And we work with English teachers, science teachers, math teachers, all in the same room. Okay, when they were doing their planning, they were all in the same room. So as they began talking about their learning objectives, Paul and I were able to listen and link those learning objectives to drones in education. And that's been a great fit for that. So now, I mean, we're taking it a step further. In Edgecombe County schools, we are working with Tarboro High School. No, I'm sorry, their middle school, to create a business analytics and drone delivery session for students. So we're now integrating drone delivery, and this was a vast majority of this was Paul's idea, into the CTE business analytics classroom. So students will not only learn to program drones to fly, but they're going to learn how to calculate the cost of putting that drone in the air, calculate the cost of, based on the battery, based on the distance and so on. So we're now, touching students in other places. So teacher professional development, ladies and gentlemen, is the key, okay? It's the key. We have to train more teachers. And our approach is explaining to teachers that we're not trying to teach you to teach drones. We're training you to use drones to teach, to visualize math, to visualize science, to visualize a writing lesson, to visualize man versus drone. That's a little pet project we're working on for physical education, man versus drone. Okay, if it takes a man this much time to run down here and go back, let's take a look at that drone and compare the two. Okay, so there are all kinds of activities we can create, but for us to have the greatest impact and create that pathway, we must train more teachers. And that's what Stimrel City focuses on. And we partner with other enthusiasts and companies to do that. And so, that's how Paul and I met. And as you can see, it's been a very good relationship moving forward. So in parting, I just want to I want to do a call to action to everybody, okay? Go back to your districts and make sure there are no drones in the closets, because there are tons of drones in the closets, ladies and gentlemen. I mean, I visit schools all the time, and when they take me to the closet, right, in the media center or in the STEM room, right, you go in there and there's these stacks of drones in closets, brand new in a box, okay? And that can't happen. If we're gonna create that pathway, that can't happen. So we need to get those drones out of the closet, get our teachers trained, and get it integrated into the classroom. And when that happens, we will weld the elementary school pipeline to the middle school pipeline. We'll then weld the middle school pipeline to the high school pipeline. And I use that welding analogy because when you melt metal on metal, it's not going to come apart. It will be solid. So if there are no questions or anything like that, guys, thank you for listening. It was truly my pleasure.
Thank you, Jeff. That was awesome. And one thing that educator, the NC North Carolina Educator UAS cohort, yesterday I was at Camp Butner with the DOT. The Civil Air Patrol was hosting a bunch of Air Force cadets and for a week camp. And part of the camp, they were exposing the campers, the cadets to drone technology. And when I saw TC Freeman, I know you, Miriam, you're familiar with TC, and there's these other folks on the call, TC with NCDOT, awesome, huge on that education and outreach side. Jeff, he was doing with the students the telos with the drone blocks and giving them the written, having them interpret that written word and kind of turning that into the mission code. And he was so excited. He mentioned the NCEUASC and how he was able to kind of connect with what you and I were putting out there and now take that. And it was so awesome to actually see it doing what it was supposed to. So it's truly exciting. I think, like you mentioned, drones as a tool to help educate. I've said for maybe a year and a half, 2 years now, drone education and then drones in education. So drone education is like educating pilots, students how to fly, how to use the software and systems. And then drones in education is more of like taking that as a tool, and I'll use your favorite word, robot, and using it as a learning tool. So Jeff, we appreciate you taking the time. And if anyone, is there any questions?
Could I ask that? I just wanted to ask a quick question of Jeff, there's a very big issue in STEM education across the country and across the world, right? We only have 5% of women represented in the aerospace industry right now. And everybody is committed to trying to bring that number up. But I really think it does have to start much, much younger, And so what are you seeing? What are the responses from the young women in your classes? Are you seeing sort of more engagement there at the younger ages?
Absolutely. I mean, when we do our sessions, we begin to, as they always say, cream rises to the top. Okay. Cream always rises to the top. And when we do these sessions, and Paul can attest to this, it's always our young ladies who are rising to the top, even with the drone build sessions. Alana, Paul, over at the Alpha Academy, she was the only girl amongst 4 boys. And I mean, she would outperform them every time building this drone. We've also seen where students at the NEAT Academy, same thing. We're really starting to understand why, the train-the-trainer model has failed us a little bit with regard to preparing our students for these pathways. We now have to focus more on giving that teacher the direct training so that we're exposing everyone in that classroom simultaneously to include our young ladies, because I'll go back to the model we're using now with CTE. It's a little different because usually a young lady will go into these classes and it's nothing but boys. So in some cases they get intimidated and they drop the class. And so if it's integrated into the algebra classroom or the English classroom or the social studies classroom, then it could be a different delivery and we can grasp more of our young ladies and get them into these programs. So it's truly about impact and, once again, broadening that net.
Great to hear. Thank you.
Is that James? Do you have a question?
I just have a comment, and I'll try to keep it short and brief. But Jeff, I really appreciate what you're doing, and I think these forums are extremely important. Several years ago, Dr. Ellie Goldratt put together a body of knowledge called Constraint Management, and it started to develop. But we agreed. I was on the national board that we needed to create a body of knowledge. Basically a bunch of written articles about it. And it finally took root, and then some books came out on the topic. And if you're a professor, you can't do anything without a textbook, okay? You just can't wing it and just say, I'm gonna teach drones and algebra and whatever. You need a textbook to go along with it. So we ended up coming up with actual text on constraints management quality. But in the Navy League, and I'm on the national board of the Navy League and their STEM committee, we developed Sea Perch, which was underwater robotics. okay? And the Sea Perch was supported by the National Science Foundation in Washington, D.C., and they wrote a curriculum. And a part of that curriculum was a train the trainer. We trained professors in teaching underwater robotics. In the Metro Detroit area, we originally had about 16 schools. We then, a couple years later, we had 38 schools. Believe it or not, those Sea Perch robots are sitting in closets right now. And there was a national competition on them. So we need to continue these forums, and I'm going to participate in as many as I possibly can and build out the body of knowledge. I think, and finally here, industry is going to tell us where this is going. And I can tell you right now, the Navy, I used to fly drone helicopters back in 2010. They were regular size helicopters, but no personnel were in them. It's called the Fire Scout. And we were flying those off of West Africa. You know, the drones are embedded in aerospace and defense. And before long, your 747s are going to be flying without pilots. I hate to say it, but that's where it's headed. Or there might be somebody there just to kind of watch all the dials. But that's where it's going. And Amazon right now is exploring the use of drones, and it will happen. Defense Department and private sector industry is going to create those job descriptions and those career paths for people that fly drones. And those people that are really talented are going to be at the top of their game, making six figures. So we just need to keep having these forums. And Marshawn, thank you, and Paul and Jeff for just staying in the game. Let's put this over to goal line. Over.
Absolutely, James, and you're correct. And you mentioned Amazon. Here we're seeing with Causey Aviation Unmanned, and I'm not just trying to shout something out, but we are competing in the likes with the Part 135, and we are seeing that if we pay attention and we listen, the industry is telling us what they need and what skills pilots need. And I think some of the research that some of the folks are doing that are going to present now and going forward will help us understand that. And then also just listening to these companies that are trying to scale and tell us it's not necessarily stick skills. It's the ability to monitor. It's the ability to have good situational awareness, attention to detail. But one thing that was mentioned, Miriam, great question, by the way, when we're talking about getting females more into this and getting them involved early so that they don't see it at a later stage and think that this is like a boys thing or it's a technical thing. It's not something that I can get involved with now. And our next presenter from Elizabeth City State University, I think this is a good transition point because what they've done recently is a camp focused on girls, young women, and a young girls only camp. So without further ado, I want to introduce Dr. Rawat with Elizabeth City State University. Thank you very much for joining us today, Dr. Rawat. The floor is yours.
Thank you, Paul, and good afternoon, everybody. And yes, Jeff, I must say that we did have this drone camp, all girls drone camp this summer, as Paul was referring to. And we used Telos. We taught them how to use Python to program Telos. And I can tell you the energy in the class, the engagement level just shot up. It was really nice and cool to see those young girls, trying to do challenges. We gave them obstacle avoidance challenges and they were excited. So it was a very successful program. All right, so I'm here today to talk more about the UAS degree program in general. And in fact, I'm going to start with the aviation program. Paul, can I share my screen?
You're muted, Paul.
Yeah, I think I can. Okay.
You should have that green share.
Yeah, I have that. Got it.
Awesome.
Can you guys see my screen?
We can.
All
And
right.
any questions, if anyone has any questions, they can put those into the chat during this, and after we'll bring those up with Dr. Rawal.
All right, so I'm going to start with talking briefly about the aviation program, then I will get into UAS. So, just to get you some data on aviation workforce shortage and needs is nothing new. You're already aware of these, but I want you to focus on the need for remote pilots, which is, expected to double. And why it's happening, because more and more companies are now buying those UAS. They're buying drones, so they need more pilots. And also someone referred to representation of women. So African-American women are heavily unrepresented in aviation aerospace workforce. Now we at ECSU, we are the university that offers aviation degree programs, a 4-year degree program. We are the only one in the state of North Carolina. And we also have a flight training component, and we own our own airplanes. We currently have 12 of those. Here are some of the students who have gone to airlines, working at Charlotte Douglas Airport. Some are managers at regional airports, even helicopter pilots with Coast Guard, so on and so forth. Now in 2019, we had expertise in aviation training, aviation education, and we wanted to build upon that and start a drone program. And I showed you the demand already. So 2019, we started this bachelor's degree, 4-year degree program in unmanned aircraft systems. Again, why are we doing that? Because demand is huge. The data is showing us, the reports, industry reports, some coming from AUVSI, PricewaterhouseCoopers House reports, they're showing that demand is huge in area of UAS. And a question that we get asked all the time by parents is, okay, after their kid gets this degree, where are the jobs? Okay, so this is a slide I always use. This is a list of 300 plus applications of drone. So if you are trained in drone, you have proper certification, proper training, you can go to any of these areas. So this is very important. So, sometimes people don't understand what all areas are out there that drones could be used for. And if they have the expertise, they can get into these applications and these industries. These are already happening. So these are some applications I collected that's already happening. Cinematography, construction site management, wildlife conservation, of course, agriculture, security, inspection, all these applications are already there. Now, looking at the opportunities for program at ECSU. Well, if you are familiar with Elizabeth City State University, Northeastern North Carolina, we have medium and large size renewable energy infrastructure. We have one of the largest wind farms in East Coast, the Amazon wind farms right here in Elizabeth City. We got the solar farm here. We have miles and miles of coastlines. We have farms. We have marshlands. And then we get impacted by hurricane every year. So all these areas are where the drones could be used for. Drones could be used for inspecting these solar panels. Drones could be used to study soil erosion along the coastline. Drones could be used to inspect these wind turbine blades. We just finished a project at Pine Island, which is in Outer Banks, about mapping marsh grasses for restoration project. And then of course, precision ag is big. And whenever there's a hurricane, you have to do damage assessment. And again, you can use drones there as well. So the 4-year degree curriculum that we offer at ECSU, again, we borrow heavily from the aviation program that we already have. So we have an aviation course that student would take where they'll learn about general aviation things like basic aerodynamics, human factors, learn about some safety, weather, those kind of things. And then they also learn about some technology because, at the end, drone is a piece of technology. And so they need to learn about some kind of programming, engineering technology, maybe some electronics, instrumentation. And then there are some courses that I take, which is specific to UAS. So we currently have 5 courses. They start with introduction, then we also teach them laws and regs and get into sensor payload integration. And then they have 2 labs. So labs, in one lab, they will actually learn how to build a custom drone for a specific application. And then lab 2 will be more about how to do mission planning, how to go on a field and actually run a mission, and then come back and then do data analysis with the data that they capture. We also have some courses that they take in business and accounting, because we do want these students to go out and become entrepreneurs, start their own business. Aviation, so it's very important they have that background. And then as electives, we want them to tap into the other majors that we have on campus. So if they take a drone, but they want to get into law enforcement, they can take some CJ classes. Or if they want to do emergency management, disaster response, they can take some EM classes, remote sensing. And then if they want to really get into rural energy, they can do that as well. And this is kind of very open. This all depends upon what the interest of student is, what specific area they want to get into. The electives allows them to choose that. Some of the capabilities, of course, the training is there, mission planning, data processing, system design. And based on the inventory that we have, there are some of the applied research that we can conduct, we have capability of doing. And as I said, we're already doing a mapping project out there in Pine Island, but there are other applications that, we have capabilities. And of course, we do a lot of outreach through our Drone Exploration Academy. And somebody new trying to get into drones, these are some of the careers. I know this is not an exhaustive list. And drone consultant, program managers, drone pilot, image analyst is huge in intelligence community. Of course, you can be a programmer. You can also be looking into logistics and supply chain that relates to drone. Or you can be a technician or a UAV test analyst. So this is our drone fleet. We have a mix of fixed wing. We use a lot of EBs. Some of you are familiar with EBs. They're SenseFly drones. We also have some DJIs, some Typhoons. And then we also have experimental quadcopter, the one that you see on the extreme left corner there. Now that's what, if someone wants to try a new algorithm, so that's something we can use, and it only flies indoors. So this is more of an experimental. But again, as I see, we do have registered a fleet of drone here. Just another picture of some of the drones that we have. And for the processing side, we use PIC40, which is pretty much an industry standard that we use for analyzing the data or generating orthomosaics, something like that. Again, we have drones, but then you need right type of sensors, and knowledge of sensors is also important for students. Based on the applications or our course curriculum, we take students through a variety of sensors. They learn about multispectral, learn about some thermal sensors. We also have a LiDAR, the laser sensor as well, that could be used for 3D mapping. And we also have a near infrared sensor. And then we have a professor on campus that also uses hyperspectral sensor when they're doing a lot of things with oceanography and those kind of applications. We also have a high fidelity US simulation training lab, where in the labs we teach students as a crew management. One is the operator, one person is flying, and the other person is actually controlling the sensor payload. And we have different scenarios for them. Currently, we have scenario for inspection. We have a scenario for poaching, animal poaching, anti-poaching. Then we also have a scenario for law enforcement. So we have set up 3 to 4 scenarios. We put students through tests and get them familiar with how to get trained in a simulated environment. This is some of the training that we have conducted with law enforcement. First responder training. And then, the same people that we have trained, actually, they come back to our drone camp and talk about their experience and how they're using drones. So we invited some police officers from Elizabeth City PD during a drone camp. I believe it was in 2019. Again, these are from our past drone camp pictures, where students are actually putting a whole drone together, and then they test fly it program it. We are also working currently on developing some US certification training. We're looking at a 4-day kind of, Part 107 training, even a longer certification, 9-month kind of certification, and then also looking into developing some seminar, maybe a day-long seminar. And again, we're going to focus on some of these topics, but except it will be in a shorter, concise version. We're also currently very close to building a drone pavilion on campus. Very soon, we should have this pavilion by end of this year. It's going to be a netted facility for students to fly indoor. And the way we are looking at this is this will act more like an outdoor lab. So we'll put a mock-ups of wind turbines, mock-ups of solar panels in there, where students can actually conduct those applications, right in this netted facility without violating any laws, because we are very close to a regional airport where we are located. We're also investing in getting into long endurance, high payload drones, especially looking into integrating drone delivery curriculum as well. We are currently at a very initial stage of that, and then also look into how we can integrate our emergency management. We have emergency management program, and how we can marry both US and EM together, and so look into applications that relates to emergency delivery and disaster recovery. That concludes my presentation, Paul, and I'm open to any questions.
That's a great presentation, Dr. Rawat, and having that manned aviation background, I think it's awesome that ECSU right here in North Carolina is providing a low cost, like it says here, affordable education. It's one of those NC Promise schools, $500 a semester. So any local, any North Carolina student, resident can get some fabulous education, and it's the beginning. Drones is a great way to get started. And if anyone has questions, drop them right here in our chat. I just wanted to, it looks like you guys are building a Top Golf out there with that net that you have going. So if it ends up being a Top Golf, I'll be out there. You might want to put a lock on that thing too, because I might be out there often. But the business classes that you guys have built into your program are phenomenal. I entered 2018, launched a drone company, didn't know anything about business. I thought that knowledge of drones would just take you to the top. And I tell everyone now, I said, learn business. Do yourself a favor. If you want to start a business, learn business. So that's great. And then Agent Butts, it was awesome to see him on the slide, because Jeff mentioned the NEAT Academy earlier, one of those high schools, and Agent Butts, I think, learned from you guys, and he did that. He went out, and then he actually connected with the NEAT Academy, and he was kind of helping the folks there. So it's awesome to see that the folks that you work with are coming back to give back to the institution, and then also carrying what they've learned forward into their own communities.
Yeah. I just want to add, Paul, you mentioned about the low-cost tuition, the NC Promise, $500 tuition a semester, and there's no additional charge for UAS training. I mean, that's so whatever you're paying for tuition covers everything. There's no charge on using simulators. There's no charge on using drones. Unlike, flight training, there's a cost to flight training, but that's not the case with drone program.
And that's an awesome point, Dr. Awat. Even in a simulator at a aeronautical university, a school that teaches flight, you're paying, it's not the same as the aircraft itself, but there's still a cost associated with that. And I think one thing that is going to really help this industry scale is the fact that you look at the airlines, the cost of simulation technology is so high that they have to the airlines have to fly their pilots to one specific location because they can't put this simulator everywhere. So to be able to have the ability to easily simulate real world conditions in multiple locations is going to help businesses scale. So thank you very much, Dr. Watt. We appreciate having you on and taking your time.
All right. Thank you, Paul.
Now, next, we're going to move on to our next panelist here with NC State University. We have Dr. Mihail. If you could pronounce your last name and just introduce yourself, that would be awesome. And the floor is yours.
I hope you can see my screen.
Yes.
Okay. So I'm Mihai Sikitiu, and I'm indeed with the NC State. And today in particular, I'm going to speak as a principal investigator for AirPo. So I'm going to introduce in a second what AirPo is. It's an acronym, right? It stands for an aerial experimentation and research platform for advanced wireless. And so first, let me try to clarify what it is, because this is going to look like a research project, but it's not. What it is, it's a research enabling project. That means what our job is to let others and invite others to come to our university to do research involving wireless communications and drones. Okay? So we are providing the infrastructure, a platform really, such that other people from anywhere in the US or anywhere in the world eventually can experiment using drones and wireless communications fully remotely. That means they interact with our infrastructure via a web browser. Right? So there's a web browser, a web portal. They come in and they say, I want to do an experiment involving one drone and one cell tower. And I want to see antenna patterns that the cell tower makes and how it's going to be, how the reception is going to be affected by the orientation of the drone. And we'll say, all right, in that case, what you need to do is to program two nodes, one fixed node representing the cell tower and one portable node or one mobile node representing the drone. And then they will do this programming fully virtual. And then we take their code and put it on a real cell tower that we have and on a real drone that we have. And I'm going to show you in a second what is that we have. And we're going to do the experiment and then return that researcher the data. We don't interpret the data, right? It's not our business, it's not our experiment, it's what the experimenter wanted to do, right? So we're providing a service for experimenters, okay? And so first I want to emphasize that this is a large project, and although I speak on behalf of AirPo, we are about, I don't know, 10, 12 principal investigators, each with about 5 students working. So it's like a 50, 60 person effort. It's a lot of work, and I'll show you in a second why. And there has been quite a bit of funding provided by NSF and a lot of other companies, including Ericsson, who donated to us 4G, soon to be 5G cellular base station, right? Completely commercial equipment. Keysight provided with us a lot of testing equipment. NI is providing us with a fully programmable software-defined radios and so on. CommScope is giving us some towers, and AT&T plans for our backhaul connections and so on. Okay, but if there is anything I want you to remember is that at the heart of our project we have programmable radios, programmable UAVs, and we are not a research project, but a research enabling project. Okay. Now, the main two things I want you to think about us having is we have a bunch of fixed nodes, which are, think of them as a first approximation as the equivalent of a cell tower. So we do have real towers, as we're showing here. This is a 60-foot tower, right? It's not really as big as a regular cell tower, but it's still decent. It's a 60-foot tower that has on it cell tower-like equipment. So antennas up on top and then enclosures at the bottom with computers. The main difference between us and the commercial cell tower is that for us, you get access, intimate access to every aspect of that computing equipment versus in a cell tower, everything is closed and proprietary and you don't get to touch it. Even if you want to do research with it, you don't get to change whatever algorithm the for handover the cell tower has, right? For us, you can change anything you want. Everything is fully programmable. And on the other end of the link, we have, again, at the first approximation, think of them as mobile phones. But again, unlike a regular mobile phone, which is a relatively closed system where you can't change anything, we have fully programmable mobile phones. And you'll see, it looks nothing like a mobile phone. It looks like this. It's a portable node. It's a 3-kilogram monster. But this is what you need to have full access to changing every little bit in there. And then these portable nodes are then carried by a variety of vehicles. Our number one use case and demand for our testbed is that the vehicle is a UAV. It's a drone, right? It's a 6-rotor drone. But we also have other things in mind. So we also have rovers that we built and are running around. We're gonna have in a year or so, we're gonna have a helikite, and we're gonna have shuttles and other things, right? So these are the main kind of equipment we're deploying. And since this is a drone presentation, I'm gonna focus more on our drones. And so this is our large drone that, or one of our large drones. We have 3 at this time. We're gonna have 7 in a year and another 3 in after 2 years. So the main thing I want to show here is basically under it. It's via quick connect, quick disconnect. We have our portable node. The drone and the portable node are completely independent of each other. The only 2 things, the only 2 links that connect them is a power connection that powers the entire portable node. It draws power from the same 2 batteries as the drone, and the data connection, such that the computer on the portable node can tell the drone where to go, right? So you as an experimenter, you get to control where the drones go by programming the computer, and we have both absolute and relative commands, like go to this location or go 2 meters up and 3 to the left, and so on. And we also allow the users to fly fully autonomous flights, meaning not pre-programmed waypoints. For example, if you are trying to find where the signal comes from a rover that you hide in the field, and you say, okay, try to find where that is. There is no good pre-programmed trajectory that's going to find you the rover, but rather you'll probably go, what is the signal here? How about here? Is it hotter? Oh, is it hotter? Okay, let's keep going that way. How about here? Cooler. Okay, let's go back. How about if we go this way? Hotter. Okay, let's keep going that way, right? So you can have you can write programs that alter the trajectory of the drone while the drone is in flight and sensing data, right? And it's the same for perhaps search and rescue, right? You look down and you say, I think I see something. Let me go down closer to see if it's, oh, no, it was just a rock. Okay, let's go back up and keep searching. So it enables you this kind of experiments to be done. Now, since the other aspect that we have is besides drone is wireless, we have a ton of wireless equipment in there. Some of it's just for the correct functioning of the drone. We have triple redundant command and control links. We have telemetry 900, and we have RC links, and then we have a cellular modem on the backhaul connected through the internet. And then we have the experimental links, and it's a bit of a headache to have that many antennas not interfering with each other on the same relatively small object. but we've done it, right? With lots of filters and careful management of the power. All these radios work without killing each other, essentially. And of course, the ones that we care most about are nobody killing our RC control and our GPS receivers, right? This is what freaks us the most. Now, in case you wonder, right, I bet nobody saw this drone ever before because it didn't exist until we made it, right? So we fully designed this in SolidWorks, and then we fully manufacture the drone, every little part, and the several hundred screws that it takes to assemble this. These are the parameters. So this has been designed at top to take off at 30 kilograms. Currently, we don't have permission to do that. We're limited by Part 107 at 25 kilograms. And we have over 1 kilowatt power hour in there. Our no payload flight time is 47 minutes with 2 batteries. We estimated that we probably can hit an hour and a half with 4 batteries, but we didn't do the test, so we don't know for sure. And we have now the open source everything, open source communication, open source autopilot. So we use Pixel 2, and we use MathLink as our communication library, and DroneKit, which is a Python library for programming. This one shows our portable node here in blue, connected to the drone. This is a CAD modeling. I'll show you. Actually, here is the live picture of essentially the same of the scenario. This is reality. This is the way we imagine it and design it in CAD. And the portable node, I didn't talk about it. It's a pretty beefy PC. It's a beefy laptop class of PC. It's a Intel NUC 10, so it's a i9 processor with 64 gigs of RAM and 2 terabytes of SSD on it. And the need for such a beefy PC is because we're processing radio samples at line speed. So there are several hundreds of megabits per second of data that need to be processed and stored on the on this computer in real life, in real time. This is what's going on. Now, in addition to the big drones, we also designed and built a small drone. And we had recently had an 82-minute flight time with a payload, right? With the cellular modem and the Latte Panda, which is a Chromebook class kind of computer on it. And it uses exactly the same flight controller as our large drones. And our primary use for this drone is to, first of all, test vehicle software. Whenever we want to test algorithms that we deem too risky for the large drone, we test it on the low drone. This is way cheaper to build and rebuild than the large drone. And second, the Chromebook that is essentially down here, it's, oh my God. And the second is, so this Chromebook computer cannot process the same amount of data, right? So we can do simple wireless experiments that we cannot do the fully programmable wireless experiments. And this is our rover. And here you can see the exact same portable node that normally stays under the drone being detached and connected to the rover. And then the rover, once again, uses the same controller, same software library. So if you know how to program a drone, the same program is gonna run on the rover, except it's not gonna take off and land because it doesn't know how to do that. But it's just gonna ignore those commands. Okay, otherwise it's gonna go wherever you want. And this is essentially how we built it, right? This is our shop bot that took our CAD files and then made our parts for it, and then our students put it together. And also, we also built the electronics, right? This is the open source PixHawk2, you recognize it as an orange cube. We didn't build that, but everything else on this board, actually this is an RFD 900, it's the telemetry, but everything else other than these two have been soldered via in-house soldering oven. So of course, I have a lot more that I can talk about, but I don't have the time. So I will wrap it down. So these are some pictures of manufacturing, and this is a comparison. First of all, between our large drone and the small drone. It's hard to tell when they're in the air, but this is the DJI is here shown as scale. You also use DJIs for filming this our drones, right? So whenever we want to showcase an experiment, we have a DJI, flying circles around our large drones. And yeah, this is our cell tower. You see something that looks very much like a commercial base station because it is a commercial base station. This is the Ericsson donation, and this is our little drone flying close to the cell tower. And this is our large drone. The LAM is large air pop anti-copter, 6 rotors in flight. Okay. And as I said, there's a lot more I can tell, but please let me know if you have any questions.
Thank you so much for presenting. This is really, really exciting. And I would just say that the drone, I'm going to drop something here. You guys going to have the LAM 6 potentially dropping the rover? Are you going to have like the drone deploy the drone, kind of like they did in, the Mars landing? I see that happening maybe in the future, but
you know what I see? I see so the rover is actually heavy. The rover is maybe too heavy to be picked up, but the SAM-4, which is a small drone, that's totally droppable. That is can go and deploy 2 or 3 SAM-4s from one of the big LAMs, like the mothership, the mama ship, dropping.
That's exciting. You mentioned this isn't a research project; it's a project that's going to facilitate the future research projects, and I think this is exciting. Is facilitating, you guys at NC State are facilitating the future, not just for students, but for the businesses of North Carolina, the country, and the globe. Eventually, what you mentioned is being able to have that ability to you've got 5 students, which working with each of your kind of leads that you mentioned. So that's huge. That's a great opportunity. And then again, for businesses to now have access to something that they couldn't afford to build themselves. I mean, you guys stood something up for things that we don't even know are coming yet. So, I mean, huge congratulations. And, the work that I know that has been put in to drive a project like that, that's awesome. And as an AUVSI, we're both air and ground. So it's great to see you guys integrating ground and air vehicles. And I do want to say, Miriam had asked, how hard has it been to get permission to fly the experimental drone?
It's been extremely easy. We didn't have to do anything because we are flying under the rules of Part 107. So we obey all the rules, right? We have the safety of pilot, visual line of sight. We don't fly over people under 400 feet and so on. So we stick to the letter. We are applying for exemptions for a few of those, but we didn't apply yet, and we didn't get the exemptions yet. So for now, we do everything. The primary one that we want to override is having 1 pilot per drone, because in our testbed we see users many times wanting to do swarms of drones, and if they're gonna have 10 drones coordinating, it may be hard to find and schedule 10 pilots at the same time showing up. So we'd like to get an exemption for that, given the exceptional amount of software that is going to overview and see what the drones are doing and the safety we have. We have a lot of safety thoughts put into it.
And I think you had mentioned that you designed that one drone that it has the capabilities to fly up to 30 kilograms, which would exceed the 55 pounds.
But we never did it.
Because the unit itself doesn't weigh above the 55 pounds and you're not operating over 55 pounds, it's not necessarily an experimental Miriam. So I don't know if that kind of
exactly
clarifies.
Absolutely. And it's super exciting stuff. And I can't wait to see when you get permission to do swarm things and so forth. That'll be so exciting too.
So we do have permission to do swarms as long as every drone has a pilot with their eyes on it and their hands on the controller.
Right.
And we already flew 2 of them at the same time with 2 pilots, but 2 is hardly a swarm.
It's a start.
It's a start, right. It's a
well, awesome. Thank you so much for presenting. And I think a lot of, what you introduced to our audience is things that like even myself wasn't quite aware of, that it's not just courses and training that we're integrating into education. It's also infrastructure that we are seeing, NC State build out, and that's infrastructure that's here in our state, and it's going to help us bring, even more businesses, individuals, education and adoption of UAS. So thank you so much.
Sure. So I do teach a course on drones, but that's not what I'm here to talk about today. Yeah, that's completely different. And when I say a course on drones, it's mostly about designing and implementing drones for a specific application.
And and that's awesome. I did have one other note great point you made is the electrical, having an avionics worked on aircraft, the electrical and mechanical engineering that you just barely scratched the surface that you guys are introducing students to is what's going to enable US manufactured drones to be produced, because we have to have the folks that can support those businesses and help them bring products to market. And if they're not experienced to that mechanical, electrical background, we're not going to see that in organizations like Flytrex, building a type certified drone. They're going to be manufacturing a type certified aircraft here in the state of North Carolina, and they're going to need employees that have a thorough understanding of electrical, mechanical, engineering when it comes to UAS. So you guys are definitely preparing students again and facilitating, that future workforce development. Thank you so much.
You're welcome. Thank you much for giving me the platform.
And we have one additional presenter who we're going to get to, and apologies, we've had some really great content, and this information is stretched out a little bit, but we've got one more presenter to come to, someone who I've had the pleasure and opportunity to meet with and train with in person, have the opportunity to work with some of the students on some of the confined space stuff. This is so awesome because we have presenters from all different aspects of the industry. And we have Dr. Ali Karamodini joining us from NC A&T University, and he's going to discuss, what it is that they're doing with UAS in his area. So thank you for joining us. The floor is yours.
Thank you so much. And you can see my slides, correct? And you can hear me very well. Okay, perfect. So thank you so much. Pleasure to be here. And Friday evening, being the last presenter, I try to keep it light. So thank you again. I think as Paul mentioned, it's a nice setup of the panel we do have here. We were having discussion on the education aspect of it and research infrastructure. I try to keep it very much focused on the research aspects of the UAVs programs that we have been doing at North Carolina A&T State University, which I think, as far as research, you're going to be impressed by the level of the effort that has been gone through this area at North Carolina A&T State University. I'm not taking all credits. Of course, it's a large group of people, students, faculties, and researchers have been helping us to push the boundaries of the research on these aspects. So the lab that I'm working with, I'm directing, is Autonomous Cooperative Control of Emergency Systems of Systems, or ACCESS Laboratory. And we are having different areas of expertise in this laboratory: control and robotics, human-machine teaming, cyber-physical systems, decision-makings, and so on, but more importantly on the application sides. So we are focusing on many applications area, ground vehicles, air vehicles, flight control systems, and so on, as well as applications, the smart transportation systems, the smart agriculture, space exploration, and so on. We have been very fortunate to receive funding and collaboration with many government agencies and industrial partners. And I'm trying to briefly review some of these projects that we have been conducting. For example, a Center of Excellence on testing, evaluation, and control of a large group of autonomous vehicles. How, when the vehicles, autonomous vehicles, and presumably UAVs are coming together, how are they behaving, the modeling and analysis aspects of those teaming of vehicles, how we can make sure that they are reliable and the communication and control aspect of it is reliable enough to make a swarm, to make a teaming of autonomous vehicles, and then eventually how again test it and evaluate it, and Tech Lab Center is trying to address those problems. Another project that we have been working with the Department of Defense is to test and evaluate UAVs, and that was with DoD Test and Resource Management Center. It was about how, from external data that we are receiving, we can understand what is the internal mode of operation of the UAVs, and based on that, we can make a judgment if the UAVs is behaving normally or no, is some failure is happening there and has to activate some, let's say, recovery or whatever that is going to be happening. Very recently, we received new funding from NASA is on secure and safe autonomy, presumably for the air on-demand air mobility. Imagining that air taxis are coming soon, then how we can ensure that sort of secure and safe autonomy for the concept of air taxis, presumably. So that was a little bit of the projects that we are doing, but also I wanted to say about the methodology that we are following in our research group. We start with, of course, theoretical aspect of it. Then we test the things on simulation environment. So we developed our own simulation environment and test how the vehicles are operating in simulation environment, because that's the risk-free, I call it, environment that you can test and do the experiments in the simulation environment. And then once you are done with the simulation environment, then you can, here are the prototypes of the vehicles that we either developed ourselves or we hacked into and implement our own algorithms. So on the left side, we can see one of the drones that we have been developing ourselves. And this is an indoor flight test that we do have. It's very in comfortable environment. We have Vicon drones, which are mimicking GPS sort of things. And we can prototype the UAVs. And on the right side, you can see one of the commercial available UAVs, which we have hacked into, and then we were able to implement our own control algorithms. And you can see how robust it is. Despite the huge disturbance that is being applied here, still it is able to control and recover the large disturbance that is being applied here. So then the students that are going through these research activities, educational activities, have been, for example, attending the American Helicopter Society. Here is one of the drones that they have been developed, and it was a very challenging competition because it was supposed to be less than 200 grams, and then less than 1 feet on each dimension. So we were having very low payload, very low size of the vehicles, and still they were able to build the drone and make it operationalize in that sense. So here is the another UAV lab that we do have, and a bunch of loops that the UAVs, they don't know the exact position of the drones before the flight, but once they are turned on, they know that, okay, here are the waypoints that they have to go through, and they calculate the path and on the flight, and then they pass through the loops and operate it. And what it is, you may think that it is fancy. Actually, it is not. I think it's you can imagine what so many applications from this sort of demonstration. You can imagine a lot of cases you have to go through narrow gates or kind of situations, and this sort of operation would be mimicking that sort of behaviors. So here is another cool experience that the students were developing, is that, hey, the UAVs, you all know that one of the constraints that everybody is crying about, it is the low operation time of the UAVs, 10 minutes, 15 minutes, 20 minutes. I was impressed by 60 minutes drone time that Mihail was demonstrating, so that was amazing. But overall, that's not the usual case, right? The usual case is pretty low operation time that we do have for these drones. So the students were facing this challenge, how we can increase the operation time of the drones. So the idea was that the flight is presumably a energy consuming operation. So how we can have this idea to increase the operation time by moving on the ground as much as possible and then fly only if needed, right? So that was a hypothesis. To increase the flight operation. So that was the kind of prototype that they came up with, and they make the operation time double in some way. So the drone is able to move on the ground as much as needed, and then once it's faced some kind of barriers, it can fly over. So let me get to the point. So that's for safety. It's not carrying. It's just we don't want it to get crazy. But that's basically what the drone is doing here. So it was, of course, first prototype, and still it has to go through so many iterations to get to the point that we can see more out of it. And then this was with single UAVs, but our primary focus in our research group is that how we can bring multiple UAVs to the operation. For example, formation control is one of those sort of things. Again, we start with simulation. So here is a simulation that again is developed in our group. So this whole simulation platform, we're very realistic dynamics of the UAVs, and a fan is here. So we are trying to see how that sort of situation happens. Then we go with ground vehicles, sort of the operations, because it's safer to reduce the risk. So here is a sort of formation using the ground vehicles, and then we move to the to a sort of on the fly sort of formation control. You can see here. Again, it is indoor. And then we go outdoor, right? So here is the outdoor operation of sort of vehicles that we do have here. So it was, so far what you saw is primarily in the lab sort of things. We have been successful also to bring this sort of research to real applications. I saw that Darshan was here, so this conversation goes back to about 2 years ago, and Darshan was one of the things that we're advocating for this project that we were that I'm going to be talking about, how to use UAVs for bridge inspection. That's challenging, and why is it challenging? When you're flying over a farm or kind of construction site, that might not be that much challenging compared to the case when you are flying around complex structures such as bridge. And the reason is that you're going to be having a crazy the airflow profile all around the corners and so on, and all of a sudden you're going to see different gas disturbances that you have to apply different corrections and operate the vehicle in that situation. So that's challenging. And on the other hand, it's very much needed. Why? The traditional way of doing this is having these snoopers going do traffic closure and so many logistics, and very expensive, $10,000 per hour. and very slow, right? So these are all can be replaced by the UAV, but the UAVs have a lot of challenges as well to be adopted. So the very first thing that we were thinking, how we can come up with an idea to test and evaluate first the UAVs for bridge inspection. Here is some of the works that we have been doing using UAVs for bridges, different sites that we have been conducting, different UAVs, let's say Falcon 8, Digital Wireless, Skydio, which I'm going to be talking about them later a little bit more. Let me also to show you one of the things that was very important, and that was based on the discussion that we had with Darshan and when he was with NCDUT and other group members that we were thinking, was how we can test the UAVs to certify if an agency is trying to adopt UAVs, they have to come up with a procedure to test and evaluate the UAVs before they're going to go through. We have been developing quite comprehensive set of experiments to test the UAVs as far as sensing, communication, RF immunity, vibration tests, gas tolerance. So these are all procedures that we have been developing. The report is going to be releasing soon. And I'm just, because of the shortage of time, I'm just sharing one of the videos that we have been doing. It was about, I think, here is a large fan that the UAVs are passing through. Right now, they are simulating, we are testing the UAVs in front of a large fan. Is about 8 mph at this point that you can see the UAVs is here. So we have been measuring, the airflow is about 8 mph, and now we are testing here Parrot and Skydio on the right side. We're gonna see how they are tolerating with respect to a sustained wind. We also have another experiment about the wind gas. We have developed a board, it was just patented. We have a board that you can mount it on the drone, any sort of drone. It is only about 50 grams, so it's not that much heavy. You're gonna mount it on the drone, and then you can pass it through airflow condition, the pattern that you do have, and you're gonna be testing how is the impact of the airflow on the drone, let's say its displacement or its acceleration or velocity in different angles that is happening there. So coming back to these presentations. So we also have been working on application of UAVs for agricultural applications, and the idea is that how we can have a group of smaller UAVs to collect aerial images across the field in a kind of collective way, right? It's going to be more affordable and doable if you go with multiple smaller, cheaper UAVs rather than one complex, expensive one, right? So that was the idea that we were working, and it has been pretty successful program, how we collect the data across the field with multiple UAVs and then put them together in different ways. The challenge here is that how you're gonna synchronize the data and merge them together when you are having multiple flights with different conditions that you are gonna be having. Coming back to the educational concept, we just, at North Carolina State University, we just established a new program. It's called Autonomy Certificate. One of the tracks is unmanned aerial vehicles, which is open to undergrad and grad students from different departments, mechanical, electrical, computational science, and industrial engineering, that they can go through this platform, this program, sorry. They have to take 3 courses plus 1 project that they have to do to be certified for this certificate. As a part of this certificate, we do have different training modules that they have to go through. For example, here is the course that we are having for drone training. They're gonna go through what is the automatic control structure, how is the sensing mechanisms of the UAVs, how to design the UAVs if they wanna design their own, how to model it, control it, and then how to develop the perception unit for the UAVs, that's part of this program. And one of the cool things I think is interesting is that bringing a very safe drones to the right. You can see this drone is called Rolling Spider. It's relatively cheap. It's only about $50. And then it's pretty safe. So the students are learning about how to control it, model it, and then use it all advanced control techniques. That's interesting about this platform. They can implement really advanced control algorithms on this platform for their education, right? And it's right, so that's a concern, how to bring the drones to the lab. So they are using their laptops, implementing their controller, and here is the drone, and it's falling. Nothing happens, right? So they can reuse it. Last thing, I would like to go back to the bridge inspection platforms that we were working on it. And here is some of the images that we have been collecting using different drones. For bridge inspection, here is a bridge at North Carolina, at North Carolina, and you can see, for example, here are the columns. A lot of deficiencies you may see, for example, here, or so you can imagine how difficult it would be to get access to those columns, and now using these drones, how much more comfortable it would be. And the advantage of this sort of using drones for bridge inspection, first of all, is you can collect the data for two columns, the space between two columns in less than, let's say, in 20 minutes, in 40 minutes, right? The thing that would take a couple of hours. So that's the first thing. Second, it is much more safer and easier to do so. And it's not that much, even with drones, we had some challenges. When we were flying there, we were seeing snake there. I got a tick bite. I personally was there. I got a tick bite. But it still is using drone. Imagine that we were supposed to go actually to all these different spots and do it, do all these. I mean, it's how grateful we should be to the technology. But at the same time, we should be aware what are the weaknesses and what are the spots that we needed that we can use drone, and what are the spots that we cannot. Right, so we have to be aware of the capabilities and the things that still we need to improve, or there is we should explore other technologies. So that's the purpose of this project. The next phase of this project is going to be how we can develop the workflow for efficient integration of the inspectors and the drones, which they can complement each other. But they cannot remove each other, right? So we cannot replace them, but they can complement each other. That's what we're going to be working on. With that, I would like to conclude the talk and thank again for listening, and any questions, I'll be happy to answer.
Thank you so much, Dr. Ali, for presenting that. If there's any questions, please go ahead and drop them in the chat. I had just taken some notes during it. And one thing early on, distance equaled safety. The ability of visual sensors required a certain amount of distance in order to sense those objects, and then speeds. The speed of the drone had a factor in that sensor's ability to pick up and recognize an object. And what we've seen with NCDOT and the number of bridges, when you're getting up underneath a bridge, when you've got these wind gusts, even if you can maintain when you have gusts, and you've shown in those videos that sometimes you get that momentary lapse in control and the movement a little bit. But to have a system that can operate and function in a tight environment, we're seeing drastic improvements now. And I think that has a lot to do with technology and flight logic and flight controllers. But No, any questions? If not, I just wanted to say, you guys, it's exciting to see that you're working directly with the manufacturers. You mentioned Digital Airless, you mentioned Skydio, and some of the others, in order to take that product and actually put it through its paces. And it's exciting to see the students working with you guys to determine, you mentioned the limitations and then procedures. Because right now we have tools, and one of the things that's kind of proprietary to businesses is some people are figuring out what those procedures are, and it's not necessarily become something that becomes readily available to everybody. When a private company figures out that golden formula, they're not running to go introduce it to their competitors. So being in that educational institution environment where you can have these students, you guys can actually identify things that you're going to then present. And Mihail had mentioned in the comments here how, this drone could potentially cost $10,000, but they're, on the contrary, they're looking at making the plans and documents completely open source so that any business, education, organization that wants to operate that product could go in and then take those plans and develop it themselves. So it's absolutely phenomenal. Miriam knows in the education space with the high schools, and it's all about sharing this information and watching us grow as a whole, because the paradigm of scarcity, for some, it exists. In some folks' minds, there's not enough to go around and they're going to hoard and take what they can. And for others, it's, hey, there's an abundance, and let's help others, figure this out, and not just figure out, but do it safely, so that we as a community can all grow together in a very safe, understanding environment, and keep that positive viewpoint on drones. So thank you very much, Dr. Ali. Not seeing any questions come up. I mean, at this point, what I'm going to do is
a couple of questions in the chat, Paul.
Is there? Okay, yeah. Well, what I want to do at this point, folks have kind of heard me talk a whole bunch, and we've gone a little bit over. So I'm going to kind of.
I see John raising his hand.
Yeah, I'm going to pass things to Kiana right now and Miriam a little bit, and let them kind of take the questions further, and then develop the discussion.
Kiana, it's all you.
All right. Well, I'll be brief on my part. I am the Education Outreach Coordinator for AUVSI North Carolina. And let's circle back to one of the questions we had at the beginning from John. This was for Dr. Rawat. Let's see, we have from John, I caught the mobile command and control unit. Did Aerial Recourse Solutions build that for you? And can you tell us a little bit more about that?
Yeah, so I sent John some information already. It was built by UAV Mobile Station. It's out of Greensboro.
Yeah, and that's awesome. I just want to reemphasize, I'm here talking again. UAV Mobile Stations, a North Carolina company, met them. They were out at the Drone Summit in 2019, and they do build mobile command stations.
And that's how we got them and got our mobile station built. So yeah.
And they also did ours. So our big, large public safety command center is from the same group.
Mute button. Maybe we have a spotlight company on the list there.
Is there any more to your questions, John?
On here. Hi, everybody. Sorry I was late today. But Paul, the last thing you said was key in my mind. We're talking to a group of educators right now. Am I correct? Yes. I'm talking to companies that are privately owned, okay, who hold on to their stuff, priority information, all this. I as some of you know, in the music business, I was very, very involved with priority software, things like that. And I had to sign 9 disclosures left and right. And I couldn't even talk about it. here are educators that are brilliant. There's people working, there's students working, they're a good cause. And I even think if I go back here, it's like I suggested I said, why don't you talk to KTI? And KTI is a company that they do software for drones individually, kind of like what Intel was doing with their parade of multiple drones and controlling multiple drones. I said, what makes your product different from what Intel is doing? He says, Intel, you have to program all your drones individually. Here, it's a network and you don't have to program each drone individually. It picks up that signature. Now that's really interesting because that saves, to me, that saves a lot of programming time. And so I don't know how good these guys are. I just talked to them. I got introduced to them. But so here's a good source. Now, the question is, will they really talk with each other? Will they help with each other? Since this is so open sourced in the educational world, these educators could be really key to these manufacturers. But these manufacturers, in my experience, and I'm not talking RTI or anything, I'm talking in general, they hold on to their stuff. How do you, and I'm going to ask the educators this, how do you bridge that gap? What do you do to ensure these companies that, yeah, we're a good help, we're a good resource, and do we, but we're open source, anybody can have that. Do you find that that is an initial problem when you're talking to a private manufacturer? That's opened up to any of the guys out there when you're really talking to these educators. I'm talking when you're talking when the education department speaks to the private sector. That's what I'm talking about.
And then anyone want to jump, Dr. Ali? So,
yep, I think there is a kind of normal procedure that we go through, and the NDAs were being signed, and different sort of protections that is being done on both sides is something that we were following. But I agree that this is a sort of challenge, and it's not always addressing all concerns, but that's the standard procedure that we go through, but still the concerns are remaining there. That's a short answer, maybe.
So the concerns are really there.
Yeah, I don't think that the NDAs is going to be solving in addressing everything there, but at least it's something, the minimum that is usually is there, and then from there we usually start conversation and saying, okay, now we can openly talk in some way.
Right. Would you then at that point sign a non-disclosure with them? Would you go as far as that?
Yep, depending on the projects, we do, and then there is also, usually all universities, they do have the technology transfer and legal office that is helping the two teams to understand the legal meaning, because I, as a researcher that I'm developing my research, may not know even the legal implications of so many terms that are there. But I think it's something that is always being there, that is helping the two sides to understand what are the legal interpretations of those terms. And based on the needs, I mean, yep, we usually prefer to work with, as a university, to work with sort of situations that our work is publishable, is presentable, is shareable with a large community. But there are special cases that we have to sacrifice that situation and understand the sponsors or collaborators, and then comply with whatever they need. And that's a special situation is always possible to be handled.
Okay, thank you. Yeah, I'm glad there's a way that you can swim through this. It's very valuable what the educators are coming up with, and and vice versa. We can help you guys too.
John, you said swim, and I'm pretty sure there's like a pool right behind Dr. Ali, so I think he might actually be swimming right now.
Yeah, that's new engineering building that we are building. It's going to be opening in about a couple of months, so it's going to be interesting engineering building there.
Great. Hope for sometime I get to visit you.
We'll be happy, sure.
Thank you.
All right, our next question was from Fletcher, and I believe this was for Dr. Situi. Am I saying that right? Situi?
Yes, Kitty.
Okay.
Yes.
Yes, so his question was, does working with NSF give you access to a certificate of authorization, or are you requesting LANCE approval?
No, we have to go to FAA directly ourselves. And NSF doesn't have any in, so to speak, with FAA. No, so we surprisingly, who's helping us a little bit is the experience of NCDOT. Darshan used to be there, and they went through this path for FAA certification before we did. So we're picking their brains on what things to do and what things not to do to get our certifications.
Thank you.
This is really why North Carolina, I think, is first in flight, is you've got all of these colleges working with the industries, working with the NCDOT, where there's normally not sort of a free flow of shared knowledge there in North Carolina. You guys have made it work. So
Yeah,
all respect on that.
This was a discussion today with Mike Wilbur over at AUVSI about you guys. You guys are just absolutely terrific. And thank you. Thank you, North Carolina.
Yeah, I see that Riley had a question.
Sure. Thank you, Kiana. My question is for Dr. Rawat, Dr. Ali. In your programs for both your universities and Dr. Rawat, I spent a lot of time with you. We spent a lot of time on the road. Can you talk to us a little bit about your programs at your colleges? And again, if you went into detail about this at the beginning of the webcast and I was late, I apologize. I've got a sick child, but I'm really interested in your unmanned bachelor's degrees. Do you guys see a certificate coming? Do you see online options for distance learners? For some of us, we have multiple degrees, but we would like add-on certificates and things like that. And this is just me being selfish and extremely interested in both of your programs. And being in education myself in the community college system, we're offering 2-year associate degrees. We're offering certificates in things like public safety and those aspects. But you guys have the real deal, the whole gamut of the 4-year BS, some master's degrees that are on the way. And I'd just like for you guys to touch on that briefly if you could.
Yeah, so I can start. Riley, we currently have a 4-year degree program that's the Bachelor of Science in Unmanned Aircraft Systems. It's a 120 credit hours program. And we are also working on developing 9-month certificate program that you could do in 9 months. And the reason we are saying 9 months is because, if you are a veteran, to use veteran benefits to do certification, it has to have that number of weeks long program. But then somebody who wants a quick, short certificate, we're also looking at a week-long kind of training. If you just have studied and have some background and you want to do your 107 certificate, you get 107 license. So we have that as well. And then we also have day-long seminars. So those are 3 things other than the degree program that we are currently working on.
And to add what Dr. Rawat was suggesting, also at North Carolina TS State University, we have a 4-year program, undergrad program, and then, of course, master and PhD programs. So the program that I am working with is electrical and computer engineering program. And we do run a certificate on autonomy. And as a part of that certificate, we have a track for unmanned aerial vehicles. This certificate is requires 12 credit hours, but you cannot take it in 1 semester because some of them are prerequisite to other credits. So it's usually an add-on to existing or our graduate or those who have already done a bachelor program. So it's add on to their bachelor program. And then they can take it and then get elevate what they have already learned through our traditional school of in electrical or mechanical engineering or whatever.
Thank you both.
And I do have a question for, is there, I don't want to cut in Keon, I don't know. Do you have anything else on the list?
It looks like Fletcher and Dash have their hands raised. We'll go with Fletcher.
Hi, good evening, everyone. Thank you so much for having this webinar today. I'm a prospective member for AUVSI New England, looking into that. So far, I've been in contact with Cascade, but this is a very good group. I really appreciate what you're doing here. And I have two questions. One is as far as unmanned traffic management tools, UTM, will any of the schools that are presented here be also be looking into the software designing of UTM, and also the cost of a drone? Like at the moment, DJI, as everybody knows, has a great drone at a good cost point. And drones that are manufactured here, such as the Autels, the price entry point is more suitable for, I would say, public safety or search and rescue operations. And I wanted to know the manufacturing, and I look at this more like the car industry, where external parts can be made elsewhere and then have them imported here to America, where they can be programmed with the firmware and the software for security reasons, of course, because we are dealing with our airspace and we would want more of a firmware and software adaptations to be developed here. But the outer shell and the parts could be developed somewhere else and entered here. So those are the two things I'm curious about, is the UTM development and manufacturing, if it could be on a global supply chain type of model. Thank you.
If I could touch on the manufacturing just real quick, because I think it might be easier. I think UTM might be a bigger discussion, but bringing the parts in, getting the parts here, and having worked directly with a US manufacturer is the most difficult part. The programming it and the putting it together, but the ability to actually get parts that are produced between shortages is what I've seen has made it very difficult to actually manufacture a US drone.
I can answer a little bit about the UTM software. I just was mentioning that we just received a new funding by NASA for the adopting the UAVs and so on within the UAM sort of things, and for air taxi management sort of things that we do have. So we are working with a company, it's called Aurora, as a collaborator, which is also is a joint company with Boeing. So we do have access to the Boeing platforms through a bridge software. That's one avenue that we are following. The other avenue that we are following, as far as the sort of the UTM management, is working with Agentfly, another company who is helping us with establishing some of those software developments that we were needing for that aspect. So these are the two things, and I'm sure that other people, maybe Darshan also, who has been working on UTM management and so on, can comment more.
Yeah, we are not working on UTM, but we would like to integrate to the UTM. So we make our testbed safer, right? To have warning when anybody would come in unannounced or even by mistake, and our testbed when we do experiments. And we also see people that do research on UTM as being good users of our test beds, or test beds I think will be well equipped for allowing other people to do research in UTM.
And if I could just add to that, at ECSU, we do have an air traffic control simulation facility, a full-blown ATC simulation ADASL system. And then we have the SimLabs UAV simulation system. So if someone is interested to connect those two and actually integrate US simulation into air traffic control simulation, that's something we can support if someone is interested to do that, because we do have a full ATC simulation facility on campus.
Darshan, you had a question as well?
Sure, yeah. My question was more towards the faculty about the degree programs and stuff. As the drone industry is, now beyond just small drones, it's eVTOL, and as Fletcher mentioned about UTM and everything, how is the universities preparing to find faculty to teach these things as the programs are getting in place? Because I know that's it's not like there's years of experience in this from many. Yes, and if there are, it'll be coming from military background, many of the folks. So has there been a thought about discussing with military on folks who are transitioning from the military to commercial to be taking up faculty roles and stuff? Just a thought to all the 3 universities.
Yeah, Darshan, we have not specifically approached defense, but when we are looking at faculty to teach these advanced courses in future, we are looking at somebody who has substantial industrial experience from the aerospace industry. So somebody who has experience with control systems. So basically, we're looking for somebody who has done US work from engineering perspective as well. So that's what we are looking at, engineering and a lot of aerospace industry work. So we have not specifically target experience from military, but we have done where person has worked with, maybe worked with Lockheed Martin, maybe that way, or even Boeing, but has substantial experience in control systems and those kind of things. Yeah. But I mean, exploring person who has done a lot of UAV work in defense would also be a good way to fill that gap and get us the people who can teach those kind of advanced courses.
Sure, and just to on offline, I'll reach out to you because we have a pipeline right now we're working on with AFWorks. I represent the US Air Force now, so we are working on certain initiatives, and I'm looking towards transitioning some of the military folks to who are moving to the commercial space, trying to see if we can position them for jobs and especially the areas that they are comfortable with and have extensive experience and which is needed in the commercial space now. So yep, now we'll carry forward those discussions offline.
Sure, yeah.
And likewise, Dr. As you may know, we have been very well connected with DoD funded projects and so on. And I'm aware of the program that you were saying. A little bit we explored it last year, but it was quite complex. So the partnership that has to be established and those requirements and so on was a little bit complex. We did explore it a little bit, but did not really push that direction. I think it would be helpful if we can get some insight from you how we can come over some of those complexity and see what is the best strategy, because the program looks like a little bit complex. Perhaps you agree with me. Right.
No, I can just give a quick thing about it, but I won't take much time. But in future, I will take up a little bit more time and discuss more about it. But the program as such, the CIVR and STT are focused for universities and research institutes and industry. Technically, compared to some of the other SIBRs out there, ours is much more easier. Just that it takes a little bit effort to understand how we are trying to get it done faster. So instead of I would say that some of the contracts that we have awarded is less than 12 weeks. And that's what, in the numbers wise, we have been pretty much the fastest in giving out contracts. So it's just a little bit of work from our side to educate, but at the same time, if you are finding any difficulty, we can tag up offline, and I can go through the process and also connect you to the right people, because that's what we are trying to do, is not just show the door, but actually walk with you along the way to get those. And we are really looking forward for research institutes and other universities to focus on STTR, because industry needs your help as you move forward. And as per the STTR requirement, you have to partner with a research institute. And there's so many companies coming out asking if we have any contacts to universities. So yeah, I will tag up with you, and we can hopefully make it easier for you.
That would be very helpful.
Kiona, I have one question. I just wanted to ask to Dr. Mihail. The infrastructure that you've put in place, we've seen that there's a list of about 10 companies, small UAS, going through type certification. Do you see the infrastructure that you've put in place being something that manufacturers that are trying to type certify aircraft might be able to leverage, especially because along with type certification comes the beyond visual line of sight, Part 135 type operation? Do you see that infrastructure being able to support those organizations or companies, and if so, how?
Possibly. That was not our first thing that came to mind when we designed the infrastructure. I don't know if I can fully answer your question, because I don't know what's involved in a certification. So in our group, I am the guy responsible with designing the UAVs and the portable nodes and making things work. But we have a second guy that Kyle Snyder knows, or I think Darshan knows him well too, Tom Zajkowski, who's handling the FAA certifications, and he knows way better than I do what it takes. So I guess that in a certification like the one you asked, the part of the infrastructure that's relevant, it's our fixed part, right? And then potentially our radios, right? So the radios that we have, they can talk to the fixed part, but then I guess they would have to certify their own vehicle, right? You cannot get a certification for vehicle A by using vehicle B, correct? I assume so. So as such, yeah. We do offer what is called bring your own device to the test bed, and so we do plan to accommodate, but I don't think it's a drop-in experience. This is not going to be one of those. I'm going to log into the website, I'm going to press a couple of buttons, and it's going to work. No, you have to email us and see exactly what they need from our test bed, and if we can provide it, then we'll be happy to provide it.
Thanks for answering that.
It looks like that's the majority of the questions we have in the chat. I know we're getting close to time as well. Paul, did you want to add any final thoughts to the presentation today?
I just really wanted to say thank you. I always get to sit in, and even on events that I help organize and put together, knowing kind of what's being presented, I'm always learning something. And I've had the opportunity to talk with Dr. Ali and train with him and his students, and I've talked at length with Dr. Rawat. But Dr. Mihail, seeing, what infrastructure you have in place. I'm very excited to see that, and being involved on the drone delivery side of things and knowing that it's, extended operations and where this might fit in is really exciting. I appreciate you guys taking your time, especially here on a Friday. I hope that the folks tuning in, whether it's right here now live on LinkedIn, on Facebook, or folks watching this in a recording, have come to understand that there is opportunities within our educational systems for students. So if those high school students with a 107 are interested in aviation, there's opportunities for them to go to schools and support this research. There's opportunities for educators, as Darshan kind of alluded to, is jobs. As these universities grow their programs, there's going to be jobs for folks with experience and backgrounds. And then in the case with NC State, this opportunity for commercial users, developers, product manufacturers, and that private side to be able to have access to work with university and students to help push their product forward, especially as we see for the US made push. I think this is absolutely phenomenal. So really, no matter what area you're tuning in from, a student, an educator, a user, there's great opportunities. You just have to, get in your car, ride out here, visit these places, learn exactly what they're doing. And I really, I can't stress any more than just to tell folks to reach out to these people. I believe, Kiana, you dropped their contact information. They're all more than willing to have a conversation. So thank you to each and every one of you for your time and attention today. And thank you for your time and attention with your students and your programs, because we need that developed workforce in order to continue to grow. And we need pilots, we need technicians, we need managers, we need folks that understand business. And thank you.
Well, Paul, just to fill in, there's a question out about the webinar. This webinar is recorded and will be available on YouTube. It's on, if you search AUVSI North Carolina, you'll have all the videos of all the webinars that we have done in the past. We'll also be emailing it. If you're signed up for the newsletter, you'll be able to see it there. And if you are on our social media also, you'll be able to see it. So we'll keep you posted when the video is live. For folks who are attending next month, Exponential, I'll be around. There'll be a couple of us also there. So if you would like to tag up, just feel free to reach out. And overall, we hope you enjoyed the session. If you have any ideas, keep sending it. We are always, rather than us coming up with ideas, we would prefer questions and ideas coming from you all. So just feel free to send it to us, and we will hopefully create a session around those ideas. And if you need certain, help, same way, we can create a whole session or webinar related to that. And hope you all have a good week and weekend. And those who I meet in August in Exponential, I look forward to that. And there's a code put out for those who are registering using AUVSI North Carolina, through the AUVSI North Carolina. It's CHNC, and it's a 10% off if you register. We don't get any benefits, but it's just discounts. That's it. So, and if you have any questions about membership or anything, please reach out to us. We have submitted our chapter for many of the awards this year for Exponential, keeping our fingers crossed. Last year, we got 2 awards, communication and was it membership? I think, yeah, membership, both we got. So let's hope we at least get one this year. And with that, thank you, Dr. Ali, Dr. Rawat, and Mihail, Dr. Mihail. Thank you, everyone, and have a wonderful day.
Thank you. Thank you for
you guys.
I say.
Bye.
Darshan, you there? Stay on for a moment.
Yep, I'm here.
All right, just stay on for a moment before I go. Hey, buddy, thanks so much.